today let's talk about complementary events. This is a continuation of our previous video on probability. So we're still going to talk about probability today, except it's going to be more theoretical. So keep this word in mind. This is the key word for today, complementary. So in general, if something is a complement, it means it goes along with something else. It could be a pair together. And there's actually a synonym called complement with an I. That's if someone says something nice about you. Okay, so that's a complement with an I. This is with an E. So a complement with an E means something is paired up with something else. So in math, what does this mean? That's what we're going to discuss today. Okay, complementary events. So there are things that go one way or the other. For example, if we had a coin, just a typical coin, there's going to be a heads or a tails, right? If we, talk about a quarter, a nickel, a dime, a penny, it's going to have a heads or a tails. One coin has to be, if you flip one coin, it has to be either heads or tails. So heads or tails, that's complementary to each other. That would be one example. Right? Or you'll see in a bit, if we're talking about the alphabet, all letters are either vowels or consonants. So vowels and consonants would be complementary to each other. So there are things that just go in pairs, right? One or the other. Let me try to think of another example. Well, generally speaking, there's day or there's night. If it's not daytime, it's nighttime, right? AM, PM. That would be another thing. So let's take a look at some specific math examples of complementary events. Okay. So back to our good old glass bowl. And we might have oranges in the glass bowl, and we might have bananas. Banana. And let me just draw one more orange, just so they don't have the same number, same amount. Okay. So talking about complementary events, let's take a look at this example bowl. Complementary events. If we wanted to say, what is the probability of randomly taking out an orange from this bowl? Well, that would be what we want. There would be 4 oranges over the total. Well, there's 1, 2, 3, 4, 5, 6, 7. 7 fruits total. So the probability of getting an orange from the bowl would be 4 out of 7. And we could make that into percent if you wanted. And here's where complements comes in. If you were thinking about oranges versus bananas, how many fruits are there total? There's 7. There's 7 total. So if I asked you, what's the probability of randomly drawing out a banana from this bowl? Well, you could count 1, 2, 3, and say 3 out of 7. That would be one way to do it. But complementary events is another way. So let me explain what I mean. If we know there are 7 fruits total in the bowl, and we know that they're either oranges or bananas, then another way to find the probability of bananas would be the total minus the oranges. 7, that's the total, minus the oranges, which is 4 out of 7. The bottom's still the possibles. And then 7 minus 4 over 7 would just be 3 out of 7. Which is the probability of drawing a banana. If you did this method here, where you do total minus our first probability, this is a method of finding the complement. And this method, you do not have to count the complement. So in this case, we can say that drawing an orange and drawing a banana are complementary events. They are complementary to each other. And the way that you know that is because if we added, let me just do the colors again here, if we added the probability of drawing an orange plus the probability of drawing a banana, 4 plus 3, the total is going to equal 4 plus 3 over 7. The total is going to equal 1. Okay, 4 plus 3 is 7. 7 over 7 is 1. So that is one of the key things to remember for today. Complementary events will sum up to 1. Or if we're talking about percent, complementary events will sum up to 100%. All right, let's take a look at another example. Actually, a couple of scenarios. Okay. So here's scenario 1. For all of these scenarios, you want to ask yourself, are these events complementary? So event number 1, rolling a 2 or a 5 on a normal dice. Okay, well, what is the probability of rolling a 2 on a dice? Rolling a 2 would be 1 out of 6. Rolling a 5 would also be 1 out of 6. If we added 1 out of 6, 1 6 plus 1 6, we would get 2 sixths. And 2 6 is 1/3. So 1/3 is about 33%. It is also not 1. So rolling a 2 or 5 on a dice, these are not complementary events. Because complementary events, if you sum them up, they have to equal 1. They have to equal 100%. So on a dice, we could roll a 1, or a 3, or a 4, or a 6. There are other options than 2 or 5. So this scenario, no. All right, what about scenario number 2? What about rolling odd or even on a dice? What about this one? On a dice, there's 1 to 6, right? 1, 2, 3, 4, 5, 6. rolling odd or even on a dice. Well, odds would be 1, 3, 5. That would be 3 out of 6. And then even would be 2, 4, 6. That would also be 3 out of 6. Right? 3 out of 6 is also half. If we added these together, we would get 6 out of 6, which is 1. So yes, this would be. Rolling odd or even on a dice, these are complementary events. Because there's no other possibility. If you sum them up, it becomes 100%. All right, third scenario. What about, as I mentioned at the introduction, picking a vowel or consonant as a letter. So we have 26 letters, we pick one at random, and we are picking a vowel or a consonant. Well, all of the letters of the alphabet, how many vowels are there? There are, A, E, I, O, U. So that's 5 out of 26. And then the consonants, well, let me get back to this at our next screen, okay? But the consonants would be 21 out of 26. And if you added these together, it would be 26 out of 26, which is 1. So yes, picking a vowel or consonant would be complementary events. And another example would be flipping heads or tails, like I mentioned earlier as well. Okay, so those would be complementary events. Now, let's unpack example 3 or scenario 3 a bit more. So back to our vowel or consonant scenario. So there are 26 letters of the alphabet, 26 letters total. If you know the vowels, A, E, I, O, U, if you know there are 5 of these, if you did not know how many consonant letters there are, what would be a better way than counting literally every letter? So what would be a better way than writing B, C, D, F, G, all the way to Z, and then counting it 1, 2, 3, 4, 1, whatever? Complements, right? We can find the number of consonants by use complements. We can find the number of consonants by complements. So if we know, like I said before, the formula would be the total minus our first event, which would be 21. And here's an example of how using complements can save you a lot of time. Okay, let's look at another example here. Okay. In a classroom, in a class, 21% of kids eat lunch from home. What is the probability of picking a student who eats lunch from school? All right, using complements, let's try this, okay? So remember, we want to do the total, which in this case would be 100%, minus our first event. If 21% of kids eat lunch from home, and we want to know how many kids eat lunch from school, well, that would be 100% minus 21. Okay. Which would be 79. So the probability of picking a kid who eats school lunch, the probability would be 79%. And we did this because 79 is the complement of 21. That's how we know. And let's try to do one more example here. Okay. So like I've said a few times, with complements, the probability of some event, something we're looking for, plus the probability of the event's complement, if you add them together, they equal 1, or they equal 100%. Another way to think about it is the probability of some event plus the probability of not that event equals 100%. Okay, so let's just look at one more example and wrap up for today. So this is kind of a theoretical thing. I can't draw it precisely, okay? But say we had 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 9. And then we have 1, 2, 3, 4, 5, 6. Okay, so say we have, there's 9 across and 6 vertically, so we have 54 total boxes. Okay. And imagine there are all sorts of colors among these 54. But a few of the boxes are blue. Okay, so I'm just going to shade a few blue. Maybe, there we go. And imagine all of these other boxes are various colors. You can fill it in as anything you want, just anything other than blue. Okay, we have some white boxes, some green boxes. The background's dark green, so we have some dark green boxes. We have some yellow as well. Shading a couple yellows here. Yellows. Alright. Just imagine that every box is filled with some color, okay? But what if I asked you, back to our original thing, Ben. So if I asked you, what is the probability of randomly picking a blue box? Well, we count blue. There's 1, 2, 3, 4. Right? That would be 4 out of 54. And to wrap up today, if I then asked you, what's the probability of picking a non-blue box? Hopefully, you can know the solution by now, which is, rather than counting every box, counting every other color, it would simply be 54 minus 4 over 54, which would be 50 over 54, or 25 over 27 if we simplified it. And this is where you see how complements can really save you time.